Hi students, welcome you all to my organic chemistry class. In today's video, we are going to learn about the different types of organic reactions in organic chemistry. Organic compounds undergo various reactions like addition reaction, substitution reaction, elimination reaction, and rearrangement reaction. Let us learn about each reactions in detail. First of all, let us learn what is addition reaction. Normally, addition reactions are undergone by unsaturated compounds containing double bonds and triple bonds or carbonyl groups and cyano groups. Addition reactions are also of three types like electrophilic addition, nucleophilic addition, and free radical addition. What is electrophilic addition? Addition of an electrophile to a double bonded compound like alkene or alkyne is called electrophilic addition. Let us take an example. This is ethylene. CH2 double bond CH2 is ethylene. Suppose ethylene is attacked by a reagent like HBr. HBr will dissociate into H plus and Br minus. And the addition will occur on the double bonded compound ethylene, resulting in the formation of bromoethane. That is, hydrogen is adding to one carbon with a double bond and Br minus is adding to the another carbon with a double bond. So, on either side of the double bond only, addition is occurring, resulting in formation of the bromoethane. Now, let us look into one more example of electrophilic addition of HBr on propene. HBr, when it is attacking this propene, HBr dissociates into H plus and Br minus. Now, the question is, where is the electrophile going to attack? The double bond is surrounded by two carbon atoms. So, which position the Br minus is taking? That is quite simple. The negative part of the adding atom will add on to the carbon atom having the lowest number of hydrogen atoms. That is, the negative part of the adding atom is Br minus. Br minus is adding to the carbon having lowest number of hydrogen atom. So accordingly, it is taking this position, and thereby the product formed is 2-bromopropane. H plus adds on to the next carbon and Br minus adds on to the carbon with the lowest number of hydrogen atoms. And this type of effect is called Markovnikov's effect. Now look at one more reaction on propene, that is attack of HBr only. HBr, when it is attacking propene, HBr dissociates as H plus and Br minus. And when this reaction is taking place in the presence of peroxide, the reaction does not proceed in this fashion. Instead, it occurs in the opposite way, which means Br minus adds on to the next carbon. Okay. In this case, we saw Br minus adding to the carbon having the lowest number of hydrogen atoms. But in presence of peroxide, the reverse takes place. The opposite is taking place, and the product formed will be 1-bromopropane. And this effect is called anti-Markovnikov's effect. And in all these reactions, there is no elimination, just addition only is taking place. That also addition of electrophile, and hence we categorize all these reactions under electrophilic addition reaction. Next, let us learn about nucleophilic addition. Addition of nucleophiles on carbonyl groups and cyano groups is called nucleophilic addition. So let us take a reagent HCl. HCl dissociates into H plus and Cn minus. And Cn minus, as it is a nucleophile, it is nucleus loving, so it goes and attaches to the carbonyl carbon, thereby forming an added compound like this. Double bond is breaking and oxygen gets the minus charge. Now the second step is the addition of H plus. H plus and O minus are attracted because of the opposite signs, and hence the product form will be cyanohydrin. This addition of a nucleophile is called nucleophilic addition reaction. The next addition is the free radical addition. We already learned that when any compound is undergoing homolytic fission, it results in the formation of free radicals. Homolytic fission is equal cleavage or equal breaking. So during this equal breaking, the bond, which is composed of two electrons, will be shared by the electrons will be taken away by both the breaking atoms. So the HBr breaks to give you H dot free radical and Br dot free radical. So when Br dot, that is a bromine free radical, is attacking propene, we get 1-bromo-propyl free radical. Okay, so the double bond is breaking here. When the double bond breaks, the electron that is left over here will bind with Br dot and it will form 1-bromo-propane, and the other odd electron which is left here is taking this position, and thereby we get the 1-bromo-propyl free radical. Next step is addition of H dot free radical, resulting in the formation of 1-bromo-propane. So this type of addition is a free radical addition is called free radical addition reaction. Next is the substitution reaction. There are three types of substitution reactions like electrophilic substitution, nucleophilic substitution, and free radical substitution. Now what is electrophilic substitution? Let us learn about electrophilic substitution by taking one example. Nitration of benzene. Benzene is an aromatic compound. When this benzene is acted upon by an electrophile like NO2+, there is a substitution of one atom. Okay, substitution reactions are those in which an atom or group that is attached to the carbon atom will be replaced by another atom. So, an atom that is a hydrogen atom attached in this position is replaced by the electrophile. It is substituted by NO2+. So, H plus is substituted by NO2+, and hence we get nitrobenzene. Since the substitution is done by an electrophile, we call this substitution as electrophilic substitution. Next is the nucleophilic substitution. Amination of chlorobenzene is a very good example for nucleophilic substitution. So this is chlorobenzene. When chlorobenzene is attacked by a nucleophile like NH2 minus, this chlorine atom is replaced by NH2 minus. So the product formed will be aniline and Cl minus. So one group, that is this chlorine atom, is replaced by or substituted by NH2 minus. Since a substitution is occurring by a nucleophile, we call this reaction as nucleophilic substitution reaction. Similarly, hydrolysis of alkyl halides by SN1 and SN2 mechanisms are also examples of nucleophilic substitution reaction. This is chloromethane. When chloromethane is attacked by a nucleophile like OH minus, this Cl minus will be replaced by OH minus. Thereby, you will get the product methanol. Next is the free radical substitution reaction. This is a molecule of chlorine. When chlorine molecule is exposed to light, it undergoes homolytic cleavage, resulting in the formation of chlorine free radicals. Each chlorine free radical can attack the organic compound methane or saturated methane compound to give you methyl free radical and HCl. This methyl free radical in turn can attack another chlorine molecule and form methyl chloride with the elimination of a chlorine free radical. Chlorine, being highly reactive species, can continue the reaction and the substitution takes place in a chain manner because free radicals are highly reactive. That's all about substitution reaction. Next is the elimination reaction. Dehydrohalogenation of alkyl halide is a very good example of elimination reaction. Elimination reactions are those in which one group will be lost from the neighboring atoms. Now look at this compound. This is bromoethane. So there is elimination of one bromine from here and a hydrogen from here. Okay, a bromine from this carbon and a hydrogen from the next carbon is eliminated as HBr in the presence of alcoholic KOH. So when bromoethane is acted upon by alcoholic KOH, there is elimination of HBr resulting in the formation of ethylene. Dehydrohalogenation results in the formation of alkenes or unsaturated compounds. Since there is elimination of HBr, we call this as an elimination reaction. Similarly, dehydration of alcohols also involve elimination of water. This is ethyl alcohol. When ethyl alcohol is acted upon by concentrated sulfuric acid, which is a dehydrating agent, can remove the water molecule from this ethyl alcohol. Concentrated sulfuric acid and heating around 170 degrees Celsius, one OH from this carbon atom and a hydrogen from the next carbon atom is eliminated as water, resulting in the formation of ethylene. Because there is elimination of two groups from the neighboring carbon atoms, we call this as a elimination reaction. It can also be called as 1,2 elimination because there is elimination from the first carbon and the second carbon. It is also called beta elimination or 1,2 elimination. Hope elimination is clear for you all. And next reaction is a rearrangement reaction. Now look at this compound. This is primary carbocation. Now this primary carbocation undergoes rearrangement. This methyl group will shift to this position because this is deficient. It attracts this methyl group towards itself and rearranging, and it is forming tertiary carbocation. Now why this rearrangement is occurring means when we compare the stability of this primary carbocation with the tertiary carbocation, tertiary carbocation is more stable than primary carbocation. So this shifting or this rearrangement does not require any reagent. Automatically this shift occurs or the methyl shifts to this position, forming a tertiary carbocation because tertiary carbocation is more stable than primary carbocation. Since a rearrangement has occurred here, we categorize this reaction under rearrangement reaction. Now look at this compound. This is N-butane. N-butane is a saturated stable compound. Now this N-butane also can undergo rearrangement reaction. But if this N-butane has to undergo rearrangement, a reagent is required. Aluminum chloride is the reagent which is acting on this N-butane during when this methyl shifts from the first carbon to the second carbon. So thereby N-butane rearranges to isopropyl butane. Okay, so after the rearrangement, we find the same number of carbon atoms and the same number of hydrogen atoms in both the compounds. In N-butane also, there are 4 carbon atoms and 10 hydrogen atoms. In isopropyl butane also, there are 4 carbon atoms and 10 hydrogen atoms, which means these two compounds are isomers. Since aluminum chloride has aided the isomerization of this N-butane to isopropyl butane, we can also call this as isomerization reaction. We already know isomers are compounds having the same molecular formula but different structural formula. Here the structure is difference is in the chain, and hence these both are chain isomers. Hope you all are clear about addition reaction, substitution reaction, elimination reaction, and rearrangement reaction. Thank you for joining.